Alright guys, so continuing on here, I want to look at number 3. And the first thing you should notice is, hey, anytime you see two right triangles that are on the same line, they have the same what? Yes. They have the same slope. Okay? So same meaning equal. Well, if you look at your answer choices and you read the sentence with a question mark, you could say, oh, these are set up as proportions. They have the same slope. And since I know slope, the formula for slope is rise over run, then I'm trying to use my knowledge of two similar right triangles, okay, assignment number 5, and the counting rise over run, assignment number 8, put them together. Well, the first thing I want you to look and figure out, hey, which are my rises and which are my runs? These lines from K to M or P to S or P to M, these are neither rises or runs. I want you to label the rise line rise. This is a rise line as well. And the run lines run. This is a run line as well. Okay, run and rise and rise. All right. So then, as you can see, it's the line segments that are listed here. K to L. K to L. That's here. That's a rise. Okay. So we can write rise here. And L to M right here. L to M. That's a run. In fact, that's a rise and a run of the same triangle. How about P to R? Here you go. P to R right there. That's a rise. And R to S. R to S is a run. Okay? And it is rise and run of the correct triangles, just in case you don't understand that. I want you to look on these particular B, C, and D. If you'll notice, M to K, let's call this line, the sloped line, that's called a diagonal. Okay? So let's circle all of the lines in the answer choices that are considered diagonals. K to M, that's M to K, that's a diagonal. That can't be a rise over run. It cannot be, because you were taught rise over run is your slope. And it says K to M is equal to the slope of PS. So there's no way that you can put the diagonal in there and say, oh, that's rise over run. Can't be B. S to P, look right here, S to P. P to S, right there. That's part of the diagonal. That cannot be part of your rise over your run. C cannot be the correct answer choice. And for the last one, I see K to M again, right there. K to M is a diagonal. All three of these is part of the diagonal. These are not part of a rise over run. There's no way that you could answer these answers correctly if you understand this question. Let's look at the next one. All right. Now, in this particular case, I've got 6 pencils at Walmart for 30 cents. Okay? And I see all of these graphs that have been given go through the origin. Well, actually, this one doesn't. This one's not an answer because it just goes straight up and down. So we can already decide right now that is not an answer. Okay, but I do have 3 lines, and if I connect these dots, I'm going to have 3 different lines that start right in the origin, and we know if it starts with the origin, it's called unit rate. And when it goes to the origin, we're going to take the y value and divide it by the x value. Okay, well, if I have 6 pencils and 30 cents, I need to figure out which one of these two is the y value, the cents or the pencils. Where would I get that information? On the graph itself. Cents are my y value over pencils. Well, in my question, it says cents is 30 over 6 pencils. To find the unit rate, you're just going to take that 30 and divide it by 6. Make sure that you hit Math 2 to go ahead and get the decimal. Okay. So my unit rate then is 5 what? 5 cents for each one pencil. So then you can go to 1, go up to the line and back over each one of these. This line doesn't even hit 1. Oh yeah, it does, way up here. Okay. So, is it 30 cents per one pencil? Is it 5 cents per one pencil? Or was it whatever that is, 2 cents per one pencil? It's 5 cents per one pencil. Because that's what you got here. 5 cents per one pencil. It can only be A. Alright, number 5. Number 5, start with a sentence with a question mark and look at your answer choices. Okay, my answer choices say, hey man, this is probably something about slope. I see a line with the coordinate points already given to me. I know one's going to be x1 and y1, and the second one's going to be x2 and y2. However, in the sentence with the question mark, which is where you should have started, it's only asking you for the y-intercept. That is where the line crosses the y-axis, and it tells you right there, when x is 0, what is y? 5. Everyone should have got that one right. Let's look at 6. Now then 6 is asking you, hey, tell me the slope of the line. Okay, so if you put your little guy here, first thing you should do is put your guy on here and say, hey, if this guy's walking left or right, is it going to be walking up or down? He's going to be walking up. That means it's going to be a positive slope. If I'm looking for slope and I know that it's a positive line, guess which ones I can get rid of? Absolutely. Okay. Now the question is, does it look more like a 2? This would be more of a 2. This would be more of a 1/2. But we're gonna solve it. x1, y1. These are the first points that your little dude is gonna be walking to. The second points are gonna be here, so we're gonna label this x2 and y2. We're gonna use our formula, y2 minus y1 over x2 minus x1. Pause the video if you need to catch up. Which one of these 4 numbers? Well, first you got to write your fraction and put your subtract signs in first. Decide which one of the 4 numbers you have labeled is y2, and you're going to put it here. That's a 1. Get rid of it. What goes here? y1. That's a -5. Get rid of it. Now I've got x2 that goes right here. That's a 6. And -6 is my last number. So make sure that you've written it properly, because it should be 1 minus a -5 over 6 minus a -6. Last step is, you got to get that in your calculator properly. You got to get your fraction framework in there and be able to know the difference between subtract and the negative sign. If you put it in properly, 1 minus a -5 over 6 minus a -6, page right. Make sure that it looks like what you've written down. Enter. There you have it. If I need that for a decimal, Math 2, And there's your positive 0.5, 1/2. The answer is C. Let's look at number 7. Now, when you read the sentence with the question mark, you're going to see the word same. That's a giveaway. And how many also. And then you look at your answer choice and say, oh, this is probably going to be an x equals situation. Okay? There's a very specific way that I've taught you to do that, and that is you're going to go find the words per, each, and every, and you're going to circle you're going to put an X over those and circle the numbers. Circle the numbers. Okay? You've got side 1 and side 2. In between these two, you've got a versus, and your versus is going to be less than, equal to, or greater than. You're going to find your versus in the sentence with the question mark, and there it is. Same means equal, so I already know I'm going to set side 1 equal to side 2. Side 1 is simply aquarium 1. Let's put a box around that. Side 2 is simply aquarium 2. We can put a box around that. And I'm going to start dropping in my numbers and my variable that goes with my coefficient right here. I've got 4.6 and I've got 1.2x in aquarium 1. For aquarium 2, I got 54.6 and 0.8x. Now, which one of these words between 4.6 and 1.2, between 4.6 and 1.2, I need to decide what goes here. Am I adding or subtracting? Look right here. There's your word right there. You don't need any of these other words. 4.6 plus 1.2x. 54.6, look right here. Draining means add or subtract. You don't need any of these other words. 54.6, subtract 8.8x. Okay? Now, you're going to solve this. One way to solve it is you could simply go through and put in your formula or your equation. 4.6 plus 1.2. And let's choose the first answer in parentheses. What if x is 148? Close parentheses. Enter. That'd be 225.4. That means the, oops, I used 184. Let me change that to 148. $182. Okay. Let's go to side 2. 54.6 and x equals 148. Close parentheses. I need to drain or subtract away 0.8. I'm doing this wrong. Subtract away 0.8, open parentheses, 148. Close parentheses, so it should look like that. You need to make sure you make it look just like you wrote it down. Okay. Enter. This guy says, does 182 equals negative 63.8? No, it does not. And you would go through to each one of these, each one of your answer choices. And you can just go up here on these calculators. You can hit enter to put back in your x value. I'm going to jump down to C to say 25, because in my brain I think that's what it is. I have 34.6. The side 2, I'll go change that to 25. And there I get 34.6 for both sides. If x equals 25, using the equation that you decoded from the words, that is when both sides are the same amount. The answer was C. All right, number 8. As soon as you see a right triangle and it says the length or distance, man, you already know. You're drawing an arrow from the right angle. You're labeling the longest side C, the shortest side A, and the medium side B. And if you don't know, you can look at your formula chart, but you should already know by now. A squared plus B squared equals what? Yep, and you're just going to drop in. What is your value for A? It is 3. I make sure you got to square that because that's what the formula calls for. Don't forget your add sign. Drop in your number for B is 9. Square that because that's what the formula calls for. You don't have the value of C. It's going to be one of these. Okay? So we'll say C squared. Now you could go and you could put this where it says C squared and see which one adds up to this same amount. First we have to calculate this in our calculator, which is 9 plus 81, which is going to give me a total of 90. What does 90 equal? 90 equals C squared. Okay? And in your lesson you should remember that that's the area of the big perfect square off of the side C. That's not C, that's C squared. What do we have to do to get to C squared? You're going to have to take the square root of C squared to get to C, and what we do to one side, we do to the other. Square root of 90, enter, 9.48. And why can that be correct? Why can 9.5 be correct? Because it says closest. Answer C. Number 9. Once again, I see that I've got unit rate situation. I'm going to go find my my numbers, and I'm going to make sure I'm going to take y and divide it by x. How do I know which one is y? Well, in this case, since I know 6 shirts, dollars, I've got dollars on this side and shirts on this side, because this is 16.5. This doesn't even go up to 16. Okay? So if my y value is dollars and my shirts are my x values, then I know I'm going to take 1650 and divide it by 6. That's going to give me my unit rate. Which gives me a value of $2.75 for one shirt. Okay, so then you just go to 1 and go up to the line, go to 1, go over, go to 1, go over, go to 1, go over. This one, it's about 22. This one tells me it's 10. This one tells me it's 15. And yep, this one's right between 5 and 0. $2.50. Once again, the unit rate at $16.50 for every shirt. For one shirt, it's going to be $2.50. The other way, on this particular graph, you could actually just go to 6 shirts, go up to the line, and see which one gives you $16.50. This is about $16.50. For 6 shirts on this graph, this is going to be well over $50. For 6 shirts on this graph, man, you're talking about $200. And for 6 shirts on this graph, again, you're talking well over $100. Not $16.50. There's only one graph that matches this situation. It's even close. Number 10.